All right, we're recording now. Here we go. Okay. Your learning target today, your learning target today, thank you so much, is that you can find distance in a coordinate plane using the Pythagorean theorem, what we just talked about and put on the back of our paper, or what we call the distance formula. So that blank is distance formula. The distance formula. I'm going to put this down just a little bit. Okay, I forgot to plug in my light. All right. Okay, so we've got this scenario here, and it says that Indira and Latoya are going to run from the southwest corner of a park to the northeast corner. First of all, do we know our directions?
Yeah.
Yeah? Okay, so southwest is here, northeast here, okay? But they'll both take a different route. So Indira decides to run through the park along a straight path, so it's marked, this is Indira's path. Latoya decides to run along the edge of the park. A scale drawing of the park is shown here. Each unit represents 10 yards. Okay, so each unit represents 10 yards. So I'm going to underline that because that will come in handy here in a minute. We need to know that. But the first thing is I want you to just make a conjecture of who is running the shortest distance. Is it going to be Indira or is it going to be Latoya? Latoya is going this path here.
Indira.
Okay, so write it down what you think. Go ahead and write down what you think. Do we all think Indira?
Yeah.
Okay, so we're going to put Indira. Okay, and since we're going to compare them, we need to know the distance of both paths. Okay, so we're going to find Latoya's first because that's the easiest, right? We can count it since we're on a coordinate plane. Okay, so if I want to, I can either count it or I can take 10 and subtract 2. How much should this be here? What is it? How many units? 8, right? 8 units here on this side. Okay. Here I'm going from 1 to 7, so how many units on this side? Not 7. 6, 6. 8. You can count it 1, 2, 3, 4, 5, 6, 7, 8. Or you can take 10 minus 2 and get 8. Okay, now each unit is 10 yards. So is this just 8? No, what is it?
80.
It's 80. Okay, so this is 80 yards. So this one is 60. All right, so how do we get Latoya's path? Add them together. So we've got 80 plus 60, which is 140 yards. All right. So how do you think that we could get Indira's path? Can we count this? No, why can't we count it? Yeah, it's a diagonal. Okay, so we can't actually count it like we did the length and the width, right? What could we use? Yes, we can use the Pythagorean theorem. Okay, we can also use the distance formula, but for this instance, since we're on a coordinate plane, we can use the Pythagorean theorem because if you look at Latoya's path, right, and we highlight that, we have a right triangle. Okay, and since we have a right triangle, we can use the Pythagorean theorem. Okay, now, if we didn't have a right triangle, could we use the Pythagorean theorem?
No.
No, good. Pythagorean theorem is only with a right triangle. Okay, so we are going to use the Pythagorean theorem. Okay, and remember that the Pythagorean theorem is a squared plus b squared equals c squared. Okay, and we're going to label what parts those are. Remember, it's leg squared plus leg squared equals hypotenuse squared. So where is your hypotenuse? Yeah, Indira's path is the hypotenuse. Okay, this is C. These are A and B. Does it matter which one's which? No. No. Okay, so A, B, B, A doesn't matter. But let's go ahead and figure out Indira's path. So I'm going to come down here. Now, if I were you, I know this says 80 and this is 60. Remember it was 8 and 6? I would use 8 and 6 and then multiply by 10 at the end because 8 and 6 are nicer numbers than 80 and 60, right? Okay, so let's use 8 and 6. So we're going to, remember we're using a squared plus b squared equals c squared. A, I'm going to put 8 squared plus B, I'm going to use 6 squared, C squared. I prefer to write X, so I'm just going to write X. You can write C if you want. Doesn't really matter. We just needs to be an unknown. We don't know it. Okay? All right, so 8 squared is? Yep, 64. 6 squared is? Okay, equals X squared. So I want to add my 64 and my 36, and I get 100 equals x squared. How do I undo a squared? Good, square root. So I'm going to undo the square by square rooting. Now, normally you get two answers. You get a positive one and a negative one. But we're talking about distance. So which one doesn't work? Negative. Okay, so we only want our positive answer. So what is the square root of 100? 10. So we know it's 10 units, but we need to make it yards, and every unit was 10 yards. So what do we need to do? Okay, times by 10, and we get 100 yards. Okay, so let's answer the question. Who ran the shorter path? Was it Indira at 100 yards, or was it Latoya at 140 yards? Good, so Indira's path was shorter. Because 100 is less than 140. Not too bad? What questions do you have? Questions? Okay, that's the Pythagorean theorem. Let's talk about the distance formula. Dun, dun, dun. Turn the page. Okay, so the distance formula kind of looks a little bit ugly, right?
Yeah.
It is derived, right? This is derived from the Pythagorean theorem. I'm not going to go into how you get there. D stands for distance. It also means length, right? We're finding length of segments or length between points. Okay, so when we use this, notice X's and then Y's. So do you remember this? Alphabetical order. Okay. I heard this one time and it was so ridiculous that I helped my students remember. I told them this is the face of a girl, right? Her hair is flowing to the side. That's your square root. Okay. She has these beautiful curly eyelashes. Those are your squares. She's kind of squinty-eyed, so she has to wear glasses. Does that make sense? And she has a very positive nose.
Looks like Jamie.
Does that make sense? It's the face of a girl, well, and she has flowing hair. That's the square root. Okay, she has these curly eyelashes. Those are the squares. Okay, she's kind of squinty eyed, so she has to wear glasses. Those are the parentheses. And then she has a very positive nose. Okay, because it's hard to remember. And then you just got to remember X's first, then Y's, alphabetical order. Now, where it says sub 2 and sub 1, it really doesn't matter the order as long as you are consistent. Okay, so if you use the first point first, then you have to use the first point first here. If you use the second point first, then you have to use the second point first here. Does that make sense what I'm saying? Maybe? Okay, so you'll get it. We'll do it. We're going to find JK using the Pythagorean theorem, and we're going to find FG using the distance formula, and then we're going to determine if they're congruent or not. Let's start with FG since we haven't done the distance formula yet. Okay, so we're going to do FG over here. We're going to find the length of FG. We need the 2 points in order to use the distance formula. Okay, so F is at 1, 2. G is at 5, 5. Okay, and now we are going to use our, bless you, distance formula. Remember, she has long flowing hair. Okay. She has kind of squinty eyes and curly eyelashes and a very positive nose.
It's not looking
Okay, and then we just need to choose what point we want to start with. Okay, remember that in a point, your x value is first and then your y value. Okay, so we can either go 5 minus 1 or 1 minus 5. If I were you, I would go 5 minus 1, and then we avoid negatives. So we're going to go 5 minus 1. And if we start with this point for our x's, we have to start with this point for our y's. So the second parenthesis will be 5 minus 2. And then we do order of operations, right? So we do our parentheses first. 5 minus 1 is 4. So we still got the long flowing hair. 4 squared plus 5 minus 2 is 3. So we got 3 squared. We need to square it next. So 4 squared is
16.
And 3 squared is
9.
okay. And then we're going to add 16 plus 9. 16 plus 9? 25. And then the square root of 25 is 5. So my distance of FG is 5. Okay? So let's compare that to JK. JK, we're going to use Pythagorean theorem. And this is how we use Pythagorean theorem here. Okay, since it's already graphed for us, we can just draw our right triangle. Okay, and then we want our legs, so we can find JK, which is the hypotenuse. So our legs, if we count 1, 2, 3, this one's 3. 1, 2, 3, this one's 3. So remember that it's a leg squared plus a leg squared equal to the hypotenuse squared. So we're going to go 3 squared plus 3 squared equals, I'm going to call it x squared. What's 3 squared? 9. And then 9. Okay. 9 plus 9 is 18. And then we are going to square root it. Now, 18 is not a perfect square. but we can simplify it. Do you guys remember how to simplify a root?
I feel like mine are like multiplied into it and the root is on the outside.
You want to find the perfect square, the largest perfect square that is a factor of 18. 9. So we're going to split it into the square root of 9 times the square root of 2. Largest perfect square is 9, and then 9 times 2 is 18. What is the square root of 9? So this becomes 3 root 2. All right, so we're going to compare them. 3 root 2, is that equal to 5? Absolutely not. So is, oh, I thought you were talking to me. Okay, so this one is JK. This one is FG. Are they congruent? No. Okay, not congruent. Okay, how do we feel about the distance formula? Pretty good. Okay, how do we feel about the Pythagorean theorem? Okay, all right, let's do the distance formula again. Okay, distance formula. Remember, it's not Jamie, right?
No.
But long flowing hair. We got squinty eyes with curly eyelashes and a positive nose. Okay, what goes in the first parentheses?
The X's.
The X's, so 3 and 9. So do we want to go 3 minus 9 or 9 minus 3?
9 minus 3.
Okay, let's go 9 minus 3. So that means we have to go 10 minus 8. 9 minus 3 is? Okay, so we've got a 6 squared plus 10 minus 8.
2.
Good. 6 squared is?
36.
2 squared is? 36 plus 4?
40.
All right. Now, is that a perfect square?
No.
No. So we want the largest perfect square that goes into 40.
20.
Those are not perfect squares. We're talking like 4, 9. It has to be something times itself, right? 4 is 2 squared. 3 squared is 9. 4 squared is 16. 5 squared is 25. Does that make sense what perfect squares are? Okay, if you don't know, write them down. So my perfect squares are 1, 4, 9. Did I miss one? 2, 3, 16, 25. Does that make sense? Okay, so largest perfect square that goes into 40? 4. So we're going to split it up into square root of 4. 4 times what is 40?
10.
So square root of 10. What is the square root of 4? 2. And then root 10. Is there a perfect square that goes into 10? No. So you're done. This is the answer. What questions do you have? Okay. Now, example 3 says a translation occurred from triangle RST to triangle UVW. We want to find the magnitude of the vector TW. Magnitude means what? Do you guys remember? Magnitude means distance. Right? Because a vector gives you distance and direction. Okay? So you might want a straight edge. I'm going to grab a straight edge. You might want a straight edge to draw your vector. So it's like a protractor or something. Feel free to come grab one. You're going to need a compass too. So you're going to want a straight edge. And our vector is from T to W. So I'm going to draw a line. You guys with me? Drawing a line, T to W. Okay, all right. T to W. So this right here is what I'm trying to find, the distance from T to W. I labeled it with an X. We can either do the distance formula or we can do the Pythagorean theorem. I personally like the Pythagorean theorem. So I'm going to do Pythagorean theorem on this one. Okay, since we just did distance formula. So here's what we need. We want to, I'm going to go ahead and draw the right triangle so I can get my legs. Because I'm going to do the Pythagorean theorem. So I'm going to draw my right triangle. I can get the legs without actually drawing the triangle. But right now I'm going to draw it. I'll show you how to get the legs without the triangle in a minute. Okay, so this distance here, you can count 1, 2, 3, 4, 5, 6. So this is 6. This distance here, 1, 2, 3, 4, 5, 6, 7, 8. So my legs are 6 and 8. So I'm going to set it up. 6 squared plus 8 squared equals x squared. 6 squared is? 8 squared is? Equal to x squared. 36 and 64. 100 equals x squared. Now what do I do? What? Square root. Thank you. I thought I heard divide. Square root. What is x when I take the square root? 10. So what is my magnitude? 10. So I have a magnitude of 10 units. Yeah. Are you okay? Okay. I did that kind of fast. Are we good? We have questions. No questions? Okay. All right, let's talk perimeter. If we can find the distance, hey, stick with me. If we can find the distance, then we can find perimeter. What is perimeter? Distance what? If I want the perimeter of this triangle, what is it asking for?
All sides.
All the sides what? Added together. So perimeter is the sum of all sides. Okay? Sum of all sides. Okay? All right. Now, the horizontal and the vertical we can easily get, right? So we've got, this one would be 5. Here we're going 2 and then up to 5, that would be 7. Now, do we want to use distance formula or Pythagorean theorem? Yeah, I would use Pythagorean theorem here because we're dealing with a triangle and we can get the hypotenuse pretty easily. Okay, so legs, 5 squared plus 7 squared equals, I'm going to call it x squared. Okay, what is 5 squared? 25. 7 squared? 49 equals x squared. What's 25 plus 49?
74.
Okay, 74 equals x squared. And we got to square root it. Okay, is it a perfect square? No. Is there a perfect square that goes into it? There's not. So it's the square root of 74. Okay, so we want the perimeter. That means we are going to add all the sides. We're going to go 5 plus 7 plus the square root of 74. So 5 and 7 we can put together. What's 5 plus 7? 12 plus the square root of 74. This right here would be the exact perimeter. So this right here is exact. Okay, now we can go ahead and round it to, right? We can go ahead and round it. So I want to make sure you know how to do this on your calculator. So I'm going to show you. Pretty easy. Okay, so on your calculator, you're going to put 12 plus your square root button. You have to push the second button, and then it's above the x squared. There's a very bright light there, right? And then 74, and then press enter. And we want to go a couple decimal places. Usually I like 2, at least 2. The more decimal places, the more precise. Shh, guys. The more decimal places, the more precise. But since there's a 0 in the hundredths place, we'll just go to the 6. So this is about, okay, the little squiggly lines mean about 20 and 6/10 units. And that is the approximation. So exact approximation. All right, stay with me. We've got a couple more problems, and this next one's a little bit of a booger. Okay, we are, in fact, this one as it's written is ugly, so we're changing it. Okay, I want you to change the 29 to a 13. I want you to change the first point S. Okay, shh, extra talking needs to stop. I'm recording. I want you to change the first point to a -2, -1. And then I want you to change the 15 here to a 10. Why are we changing it? Because you will thank me for the numbers I just gave you. I've made it a lot easier for you. We can do it as is.
No.
Okay.
No. No, thank you.
All right. You can do this 2 ways. Okay? You can do this 2 ways. I'd like to do this 2 ways, but I'm going to show you the Pythagorean theorem way first. And then if we have time, I'll do the distance formula. Okay? But I'm going to draw this first. Okay? So we have this segment. Okay? It doesn't matter how we draw it because we're not on a coordinate plane. But I just drew it horizontally. So here's our segment. Okay. Shh. Okay. It's saying that the distance between S and T is 13 units. Okay. It's saying that S is located at the point -2, -1. And T is located at the point 10, Y. And we want to know what the value of Y could be. Okay. Now, here is how you get your A, your B, and your C when you're doing this. All right? Okay, your A is going to be the distance between your X values. Okay, so A is going to be the distance between your X values. So from -2 to 10, how far is that? 12. So that's your A. Your B is going to be your distance between your Y values. Okay, so when we do distance, remember we're going to take Y minus your other Y. We're going to start here and subtract. So Y minus -1 is actually a Y plus 1. Are you with me?
Yeah.
Okay. So this is a Y plus 1. C is the distance between the 2 points. 12 is from -2 to 10. So it's 10 plus 2. 10 minus the -2. Okay. Now we can do the Pythagorean theorem. So we've got 12 squared plus your B is a binomial, so put it in parentheses, plus Y plus 1 squared equals 13 squared. I don't even know what that was. Okay, 12 squared. What's 12 squared? Good. Okay, plus, remember that y plus 1 squared is y plus 1 times y plus 1. And you need to double distribute. Y times y is y squared. Okay, y times 1 is y. Y times 1 is y, so I have a 2y. And then 1 times 1 is 1. So plus 1. This ends up being y squared plus 2y plus 1 when you distribute. Okay, equals 13 squared is 169. Okay, now we're going to go ahead and get combined like terms. 144 and 1 is 145. Okay, so I have y squared plus 2y plus 145 equals 169. And notice I have a quadratic. So I have to get everything to one side. So I'm going to subtract the 169 because I need to make it equal to 0. So y squared plus 2y, 145 minus 169. Negative 24 equal to 0. Okay, how do I solve a quadratic?
You do like the magnitude.
Okay, so like factoring, we could factor. Okay, we want to multiply to get negative 24 and add to get 2. So if we're multiplying to get a negative, one has to be a negative, one has to be a positive, right? Okay, factors of 24 would give me 2. 6 and 4. Which was positive, which one's negative?
The 6 is positive.
Good. 4 is negative. So we go to y minus 4 and y plus 6 equal to 0. And since we want to know what y is, we actually need to solve. So y minus 4 equals 0, y plus 6 equals 0. So what could y be? 4 or? Good, 4 or negative 6. So y could be 4 or negative 6. It can be a negative because it's part of a coordinate point. It's not a length. Okay? So we're trying to find the y value of a coordinate point, and coordinate points can have negatives. Okay, questions on that one? Nope, okay.
Are you gonna like a little bit
Do what?
You're gonna give it to us this one, maybe?
Am I going to do what?
Give us homework like today, or you're gonna
Today. We'll give it to you today. Okay. Again, what does magnitude mean?
distance.
Yes, distance. Distance. Okay. Now, resultant displacement. Resultant displacement is your hypotenuse. Okay? It's where the bird started to where the bird ended. Okay? The shortest distance from one place to the other. Okay? So it's going to be your hypotenuse. Okay, and here's what I mean. So this bird, here's my bird. Isn't it a nice bird? Okay, it's great. 5 miles south. It goes 5 miles south. And then it says 5 miles west. Sorry, 3 miles west. This bird is very exact in its flying. Now my bird is here. Okay, so the first question is, how far did the bird fly? How do I find that? 8 miles. So the bird flew 8 miles. Okay, now we want to find the magnitude of the bird's resultant displacement, meaning we want to find where the bird was to where the bird ended up from point A to point B, right? This is going to be my resultant displacement. That's what I'm trying to find. In this instance, we cannot use the distance formula because we don't have points, right? We have to use what? Pythagorean theorem. How do we set it up? Equals x squared, right? Okay, does everybody understand how to set it up? Okay, we're going to have to stop here because we're about running out of time. But I do have some practice for you.